Hi students, let us continue module 4. In this module, we will be learning compiling and running a simple parser, that is Yak program, and next topic is arithmetic expression and ambiguity. So how to compile and run a simple Yak parser. So on Unix system, Yak is your grammar and creates y.tab.c. So Yak what does it do? Yak will generate the grammar and it will create a y.tab.c file, and it also generates a header file called or it is also called library file y.tab.h, in which it will define the tokens. Lex creates lex.yy.c and the C language Lex. So Lex tool it will create a lex.yy.c file. We need only compile them. We need to compile them together with the Yak and Lex library. We need to compile them with Lex and Yak library. For example, the library contains available default version of all the supporting utilities, including a main that calls the parser yy parser and engine. For example, you have written a program, Yak program named chapter 3 underscore 01 dot y. So how we can use the Yak tool? So we should write Yak. Yak minus v and a file name chapter 3 underscore 01 dot y. So it will create y.tab.c and y.tab.h. So this line it will create two files. One is C file and another is H file called y.tab.c and y.tab.h. Next, let's chapter 3 underscore 01 dot l. It generates the C file. This Lex it generates the C file called lex.yy.c. Now we should compile both the C files, that is chapter 1 dot cc minus c, chapter 3 underscore 01 y.tab.c and lex.yy.c, and we should link it minus l with the library function. Compile and link C files. Then the output name will be chapter 3 underscore 01. We'll run it and then we'll enter the input. Suppose 99 plus 12. It will give you 112. So this is how we can compile and run a simple Yak program. First of all, we should compile with Lex and Yak. Then we should compile with, they will generate the C file. Then we should compile with C compiler. C files will be compiled with the C compiler. Then they will generate the Lexer, and in which we should enter the input and value will be calculated. Next is arithmetic expression and ambiguity. Suppose let's see the arithmetic expression here. Expression, it generates expression plus expression. Its corresponding action will be $$ equal to $1 plus $3, which already we saw in the previous video. Or expression minus expression, it can be $$ equal to $1 minus $3. Or expression into expression, it can be $$ equal to $1 into $3. Then expression divided by expression. But division it will be possible only if $3 is not equal to 0. If $3 equal to 0, it will generate an error, yy error, divide by 0. Else $3 equal to $1 by $3. If minus expression is minus expression, then $$ equal to minus of $2. And if left parenthesis expression, then $$ equal to $2. Here this left parenthesis it is a $1 expression is $2. Then number $$ equal to $1. But this grammar has a problem. It is extremely ambiguous. This grammar it is extremely ambiguous. Why it is extremely ambiguous? For example, 2 plus 3 into 4. It can be 2 plus 3 whole into 4 or 2 plus 3 into 4. It can be anywhere. So for this input string, this grammar, it will generate two parsed. For example, here we have expression. Suppose it is a statement. Its statement is expression into 4. This 2 plus 3, suppose it is a expression. So expression into 4. Then expression, it can be 2 plus 3. Second part still can be the statement 2 plus 3 into 4. It is kind of this 2 plus expression, and expression equal to 3 into 4. So for the same input string 2 parse tree, it is generated. So it is called ambiguous grammar. At this point, the parser looks at the star and counts either reduce 2 plus 3 using expression plus expression to an expression or shift star expecting to be able to reduce expression into expression later on, and all like that only it will be uh, ambiguous grammar. So to remove the ambiguity, two things we can do. We can add the precedence control, which operate to execute first in an expression, and associativity controls the grouping of operators at the same precedence. So precedence rule and associativity rule, two things we can apply. For the example, now there are two ways to simplify precedence and associativity in the grammar: implicit and explicit. For example, to specify them implicitly, rewrite the grammar using separate non-terminal symbols for each precedence level. For each precedence level, we can use the separate non-terminal symbol. For example, expression colon expression plus multiplication expression, or expression minus multiplication expression, or multiplication expression colon. Multiplication expression can be multiplication expression into primary, or multiplication expression mul expression can be mul expression divided by primary, or primary colon. Primary, it can be left parenthesis expression, right parenthesis, or minus primary or number column. So that is all about the rule section. The third section of the Yak parser is auxiliary routines. So in the auxiliary routines part is only C4. Main and all will be written. So it includes function definition for every function needed in the rule part. In the rule part, whatever function we have used, all function definition will be written in the auxiliary routine function. It can also contain the main function definition if the parser is going to be run as a program. Okay, so main function will be written in the auxiliary routines part only. The main function must call the function yy parse. So in main function only, we must call the yy parse so that all the things gets executed properly. And like this, we finish module 4. Thank you very much.